So first of all, I will introduce myself. My name is Vishal Patil. I am an application engineer here in SOPAN Infotech Pvt Ltd. We are authorized reseller of Dassault system and Hexagon products. They are mostly famous companies for their CAD, CAM and CAE domain softwares. Okay. So we in the Gujarat region, we are the reseller for it. So for the Dassault system, we have three softwares mainly as a widely renowned software, that is a SolidWorks, which I can say it is a 3D CAD solution. Okay, and the second is a draft site, which is a 2D CAD solution where we need only 2D drawings or layout design solution. So we have draft site for that, and the newly launched 3D experience platform where everybody can collaborate, whether it is a engineering, whether it is a commerce field, it is a business field. Okay, so everybody can collaborate with this platform. Okay, in the hexagon manufacturing industry is a we have in the cam domain, that is esprit for the cnc solution cam solutions, and for the sheet metal industry we have radan software, and for the die and mold manufacturing solution we have vz. Okay, so these are the our main portfolio. We also give the engineering services to the industry. So let's move on to the today's topic. So as you already know, the topic of the webinar is best practices for managing SolidWorks large assembly. This is a very much awaited webinar because lots of SolidWorks users tend to ask me during their visits and any event, the SolidWorks has large assembly cannot perform very well. So today's my task is to give the solution for it, give the management practices or best practices to you guys. How can you manage large assembly in the SolidWorks? Okay, so we will just move ahead. So in today's webinar, what we will cover: first, what is large? Okay, in the SolidWorks terms, what is large? It has some specific terms. So we will see how assembly can be open in different modes to perform very smoothly. We also see assembly tools where we can optimize the performance of the assembly using utilizing this kind of tool. We will see also that tools and the last one is the modeling techniques. Okay, so these four domains we will cover in this webinar. So first one is what's large. Okay, so all you might know that SolidWorks is used for design a product where n number of components are assembled together. Okay, so we can say the large assembly for 100 components also, for the 1000 component also, and for the 10,000 component also. But what is large? What is the maximum number? Okay, so I will tell you that there is no any large number. Okay, the large assembly means any assembly complex enough to max out your system resource and hurt productivity. Okay, so हम बोल सकते हैं कि लार्ज असेंबली की जो हम हमारे पीसी में या हमारे जो हार्डवेयर है उसमें जब हम वो असेंबली ओपन करते हैं, so whether it is 100, 1000 or 10,000, okay, if it's stuck, if it is not performing very well, okay, so you might say this is a my large assembly for my particular system, okay, particular hardware. Okay, so what are the symptoms of the large assembly which slow down your performance? What are the symptoms? Okay, the first one is the opening or saving. When you open any assembly file or saving any assembly file, you find or tend to see some lags or some very huge time taking to open and saving. So this is one of the symptoms of the low performance. Performing rebuild, when you make some changes in the assembly and try to rebuild it, it takes time. Also in a rotating and zooming, while you moving a components in assembly, you also see some slow performance. While adding mates, okay, you can also see the performance down. And also obviously making drawings, because all that assembly are reference into the final output, that is a 2D drawings. Okay, so these are the symptoms of your slow performance. So what to do about it? Okay, so we will see step by step how can you neglect those low performance outputs. We will see. For that, only two persons are, or I can say that two objects are cause that problem. Okay, one is 30% under the SolidWorks control and the 70% under user control. Please keep note that the SolidWorks has all its algorithm works very well if user can create in a particular scenario that computer and software language can understand. Okay, so it's users responsibility that they have to create and edit those assembly strategically, which can SolidWorks as well as your computer hardware can understand. Okay, so we will talk about it later in this webinar. So how can this the software understand and the computer process the data? Okay, so first domain is obviously the hardware, where you use your SolidWorks software or any CAD software basically. Okay, the first main important, the hardware is your CPU. Okay, see what does CPU? It only processes the data. Okay, the common lots of misconception to the user that CPU does all the things. It loads graphics, it saves the temporary memory and all these things. It is not. It is wrong. CPU only processes data. Whatever you do in the computer, it only processes the data, do the calculations of the data, do the algorithms. All the backend process are done by the CPU. Okay, this is basic thing, but it will clarify your thought process, or when you next time creating some task, you will got to know that no, CPU does the process data. So you buy the CPU according what your need for the processing. Okay, every component has its limitations. Okay, not everybody has every capability. Okay, every hardware has some limitations, so that processor also. Okay, when we count the processing unit, it counts in a MIPS. Okay, it has units, million instruction per second. Okay, every processor has some limits that can, the per second it will process the millions of instructions. For that CPU core I have shown in the image has 35 billion instructions per second can process. So likewise you have to analyze the data or analyze the process that you want to process. You have to select the processor according to its specification. Next is the hard drive, where you store all your data, digital data I can say. Okay, in the latest domain, the SSD, solid state drives are in the market. Those are very fast and high performance. Okay, so those who are using HDD, you should replace that with the SSD. Okay, because it has a very ultra speed of handling data. Okay, it has very less noise, more energy. Okay, so this is the one upgradation you have to do for your processing the data. The third one is the RAM, random access memory. What does RAM do? Okay, it stores data memory for the processor. बेसिकली रैम एक ऐसा हार्डवेयर होता है जो क्या करता है कि सपोज प्रोसेसिंग करने के लिए, सीपीयू को प्रोसेसिंग करने के लिए कुछ डेटा रिक्वायर्ड होता है, तो वो एक्चुअली रैम से उठाता है. ओके, रैम से लोड करता है. तो आपकी जितनी बड़ी या जितनी कैपेसिटी ऑफ ब्रांच जितनी ज़्यादा होगी उतना ज़्यादा प्रोसेसर को मिलेगा ताकि वो प्रोसेस कर पाए उस डेटा को, मतलब सीपीयू को उतना डेटा मिलेगा. Okay, so this is a scientific terms, please understand. These small things contribute your performance. Okay, so you need to take the decision that I want to upgrade my hardware or just increase the capacity or try to different configurations. Okay, so for the SolidWorks I will recommend that it is a 16 to 32 GB, because nowadays a development are going on, a very huge amount of R&D is going on the SolidWorks software. So basically that needs a very not very just moderate of RAM capacity, 16 GB. Okay, that is available in the memory of the mobile. So in the past decade, we use 1 GB and 2 GB mobile memory. Nowadays, it is 16, 30 to 64, like 128 GB RAMs are coming. So likewise, as software develops, as technology develops, it requires more performing enhanced system also, hardware also. Okay, and the last one is the graphics card. What graphics card do? It only fill triangles per second. Okay, I will later on the stage I will elaborate कि fill triangles क्या होता है. Graphics card का purpose क्या है actually? It just graphically enhance the visuals of the your screen. Okay, ये just ये CPU and graphics card are two different things. CPU process the data and graphics card process your graphics visuals. Okay, in the later stage I will elaborate what is field triangles. Okay, for the SolidWorks user, you must be use certified graphics card, because every software has different algorithms. Okay, that not suitable for all the graphics card in the market. Okay, they are check the data analysis which company has maximum user of graphics card. Okay, so that research give the algorithm to perform their software, build their software. Okay, so SolidWorks has certified graphics card. Please do the checks. So I will just suggest here NVIDIA Quadro series graphics card are most suitable for the SolidWorks. It boosts your performance very high for the in terms of graphics. Okay, so that is my suggestion. If you have any query about this, if you have any doubt or decisions you have to take on for the hardware, I will suggest go to the website I have shown on the slide. Okay, you will find this hardware certification for the SolidWorks performance. Okay, so go to the website, input your hardware system, check it is suitable or not or certified or not. Okay, the next thing is the file location. The file location where we store the file, where we save our SolidWorks files or any CAD file. Okay, it matters, because if you load the file from the local or local hard drive, or if you load from the network drive, it performs differently, because in the network it goes from server to your drive, it compile, okay, and then it again goes to your the LAN system and then your PC. Okay, that is the process. So you have to check whether you want to go for the network. If you find the assembly it's lagging very slow, so you have to collect those data which is on the shared network, you have to grab it on your local PC and then open it and perform the assembly functions. Okay, so file location really matters. So keep in mind that if you have the file location on your local PC, that is be very take less time rather than network. Now we will understand when you open any assembly what the process the file will go on. That is we have to understand, because when we open the file we have to first analyze that what we have to perform on the assembly. Okay, because we opening the file because we have to some work, like maybe it is to view the assembly, to animate those mechanism, or you want to add some components on it, you have to some just modifications. Okay, so we have to first think before opening the file what we have to do on in the assembly. Okay, so first you open the assembly. First, it will locate and load components in files in a RAM. Okay, I already mentioned that RAM, the first element where data registered for the processing. Okay, so when you open the file, whatever your components, because assembly has some components data that will load on the RAM. Okay, and locate the all these components, and then processor tells the RAM that any changes since the last step. Okay, so the CPU, the brain of the computer, tells the software that any changes is happening in the last opening. Okay, if it is no, then it will directly commute tessellation. Okay, I will later the on the stage what is tessellation, I will later the stage I will highlight it. Basically graphic triangles. Okay, what it will look like I will just explain in the later of the slides. So if there is no change, it will directly go to the graphics triangles and your assembly will open. Okay, for the editing, right? That is very simple. If any changes not happen before the opening of the between the two stages of the opening, okay, then it will very short path, it will take less time to open. If any changes since the last save, if it is yes, it will first update those out of date components. Okay, so there changes any happening, it will rebuild all those changes. Okay, and then proceed to the locate components. Okay, now it will locate as well as it will solve also mates. Okay, because you have changes, so processor again do the calculation for the your mates. Okay, whatever the mates you apply to those components, it will again calculate. Next, the first mate pass, if it is yes, then update in context and assembly features. Then later stage आपने जो भी इन कॉन्टेक्स्ट, मतलब आपने कोई एक कंपोनेंट का रेफरेंस लेके कोई दूसरा कंपोनेंट बनाया है, तो वो पहले अपडेट होगा और बाद में जो रेफरेंस कंपोनेंट है वो अपडेट होगा। और आपने कोई असेंबली फीचर का यूटिलाइजेशन किया हो, जैसे कि कोई आपने कट होल विजार्ड से होल्स बनाए हो, पैटर्न किए हो असेंबली में, ओके, देन वो अपडेट होंगे। हैज एनीथिंग मूव, ओके, सपोज आपने असेंबली में कुछ मैकेनिज्म मूव करवाया या कोई सब असेंबली को फ्लेक्सिबल करवाया, तो वो अगेन कैलकुलेट करता है। इफ इट इज नो, okay, then it goes to the computer graphics. If it is yes, again it will locate the component and the cycle will continues going on. So keep in mind, all you do in the assembly, it affects your performance. If you have to wisely think what I have to do, what I have to do the next, why I am doing this question you have to first understand. Okay, this is very critical for your performance. So you can see the in these graphics how your assembly going to load in the backend. It will perform all the components in its features, detailing, changes. It will do in the backend of the your software. So now you can see the graphically what is going on the background of these when we open the assembly, and takes time. It will, or it will takes to time to rebuild and correct all the data, calculate all the data, process all the data, and visualize in front of you. So it takes time, but you have to keep update those files before opening, and the graphics performance you have to boost. Again, opening a drawing and simplify, it is also applicable for drawing also. How when we open a drawing, it also takes the time, because it update all the configuration of the assembly reference by drawing. Okay, whatever the data, whatever the views you have placed in the drawing sheet, it updates because you need the accurate data. Okay, so it will reference file first update. If it has some changes, that cycle will go on and then update, then you will get those views in your drawings. Next, it will show all model projected views in a draft quality. In the draft quality, if you select all the in the high quality views, it will also in the background it will continues to process. If you have placed some views and which are dependent on the other views like detail view, section view, okay, the projected view dependent views, then after that process. Okay, so you have to when you place the dependent view, you have to think about it. You don't if you in a single view, if you are taking two views out of it, you have to first think that two views are on a single view, because if you take the different views of the different dependent views, it will take more time. Then it will process other items like layers, line fonts, your annotations, your symbols, all this stuff that load, and finally your drawing will open. Okay, so if those who are facing heavy or large assembly takes too much time to update and too much time to save, so the user should understand this process is happening. So when we building the drawing, we have to build in such a way that it will take less time to process. The next is the feature detailing. Okay, every sketch, every vertices contribute to the later on the stage in a feature. What is feature? Feature is just a creation of the step by step building block of any object. Like for example, we will extrude is our feature, hole wizard is our feature, revolve, loft commands, sweep command, these are our features. That is a building block for creating any 3D model. Okay, so whatever the feature you are creating, you contribute to the its performance. Okay, so you have to be careful, the whatever the feature you are creating, you have to optimize and rethink in less features. How can I create this model? So in the graphics card stage, I am highlighting the fill triangles. Okay, what does graphics card do? In the slides you can show that in a on the left, extreme left hand image, that is the realistic image, okay, of the shaft that we are seeing in the software we built in the software. It is look like this. What software and computer understand, which is the middle of the view. Okay, it sees only this data, and what we see in the software, that is in the right, extreme right of the view. Okay, so what graphics card do? It will fills all these triangles. You can see in the middle of the image there is a, the object is divided in the n number of triangles. Okay, that is called as a graphics triangles, or in a technical word it's a tessellations. Okay, so when you create the feature, the tessellation will increase, it contribute to the memory of the file. Okay, and ultimately it goes to the performance of the your graphics. So graphics card, if you have higher capacity of the graphics card, it fill these triangles very rapidly. Okay, if your graphics card is very low, it takes time to fill these triangles. Okay, to show the extreme right view graphical image in the SolidWorks. So in this way you have to choose your graphics card, what capacity do I need to process my graphical data. Okay, So we will see the example how graphics triangles contribute to the performance. uh, you can see in the slides that there is one model, okay, with fillets. All the fillets I have applied into this model, and you can see the file size. Okay, it is 1945 kb with the fillets. When I remove the fillets, look the memory size, it is only 622 kb. Means what I want to conclude that every feature you are taking into the model, I confirm that it is a modeling need or a design need. Okay, but you have to wisely select or wisely contribute to the non means optimize these features, because it ultimately contributes your file size and indirectly your graphics. Okay, your graphics triangles. You can see with fillet it has a 33,726 graphics triangles. Okay, and with no fillet 7,382, which means with no fillet the model will open very quickly as compared to with fillet model. As simple as that. Okay, so you have to, every feature you are creating, you have to optimize, you have to rethink, you have to make some understand that whatever I am creating, I must optimize those data. Okay, because it ultimately leads to me the assembly performance. Also, the second topic is the image quality setting. A lot of user use very high settings because we want to see in a very clear moment, but it is not mandatory, because we want data to be accurate, not visually accurate. Okay, so you have to take the right step to create in a lower side, because you have to work on it. When you just visualize, you can take it on the higher load, but it take time. So if you have to work or edit, you have to take this assembly quality, image quality setting to the lower side. Okay, likewise you can see for the image quality you can improve, it will leads to your graphics triangles also. Okay, so you have to wisely use those quality image setting. Also, the number of configuration it can lead to the number of graphics. If it is n number of graphics, it tends to n number of triangles of your CAD data. So you have to think about it, what numbers of configuration I can add or I can optimize in between 2 or 3 files. Okay, if your assembly performance is very poor, so you have to take that decisions also while creating the configurations of the 3D model. Second, the most important, that is the met complexity. Okay, I see a lot of user are has SolidWorks has a very dynamic and very feature rich tools where you can optimize or you can reduce your number of mates. Okay, suppose you want to add some fastener to these 4 holes that I have shown in the image in the bracket. Okay, so what does the user does, it will adds all 4 holes of the mates to the fastener. Okay, it is not valid. You have to just insert one hole and pattern all the bolts. That simple, it will reduce your mates. Okay, so you have to, in this way you have to think the mate complexity. Don't excessively add the mates which is not necessary. You have to just use the extra command for it, so it will reduce your mates. Okay, the next one is the assembly feature complexity. Okay, when you creating any assembly, if you take the reference of the other geometry, okay, other parts geometry, and when you load those two components in the assembly, it takes the reference of it. Okay, the binding terminology will take time to utilize those data to process. So assembly feature complexity you have to use wisely. Assembly patterns and assembly features also takes time to rebuild at the assembly stage. Okay, because you opening the file, that features also will rebuild to give your accurate data. Also, you have to neglect all the errors. Okay, it may be the rebuild error, it may be mate error, it may be the equation errors. Okay, you have to solve each and every errors, because when you open the file with errors, it will ultimately gives you the poor performance, because the computer, the RAM, the CPU try to solve those process. Okay, it will continuously work on that process algorithms that this has to be corrected. So you need to clear all the errors. Okay, you made some mistakes, you have to just step by step go to the every errors. Software does all the information. If you go in an error, if you select any error, it will show you why that error is occur. Okay, so you have to go to step by step and not all these error to eliminate those error in the assembly. So it will give you the clear and crisp performance. So now we will see how the data structure leads to the performance. Okay, for this the CAD software domain, I will say it has a three important parameters. First is the geometry, second it's graphics, and third is parametrics. Okay, so as we are the engineers, we need parameters to create any engineering model. Okay, so we use a CAD software, parametric CAD software. For the geometry, we have three important elements. First is the surface, or we can say face, edges and vertices. Okay, so these are the geometry that conclude into the data of the geometry. Graphics, it has, I already tell you that every object you are creating, it leads to some graphical triangles, it creates some graphical triangles. Okay, that triangles leads to your graphics. So you have to this is the data structure for the graphics. And the last one is the parametrics. Okay, where you create features, mates, equation, every terms where we put some value inside the commands that leads to parametrics, means that data has to process, that data has to calculate some calculate and analyze those data to give you the accurate data. So you have to understand these three important pillar of your data structure in the CAD software. First is the geometry, second is the graphics, and third is the parametrics. So this is the first session that we see the what's large. Okay, it for the sum up, it has takes your hardware capacity to full of its extent to perform all your data structures. Okay, now we will see various assembly modes so you can take your performance enhance. So basically, SolidWorks gives you the three assembly modes. Okay, from SolidWorks 2020, it has resolved, lightweight, and large design review. Okay, we will see step by step one. For the resolve mode, it will load all the three domains that we actually discussed, that geometry, graphics, and parametrics. When you select the resolve mode, it will open all the three domains: geometry, graphics, and parametrics. Means you can see your all the models with accurate details, with you can modify at any stage, whether it is a geometry, whether it is a graphics, or whether it is a parametrics. Okay, so when you open in a resolve mode, all your data accurately load inside your software. The next one is a lightweight mode, where you can it can load only the geometry and graphics data. Okay, so it will not create a parametric data. Okay, so it your all the values that you have put in the mates, in the features, in the your equations, all that data here it cannot load. So assembly for the opening your assembly in a lightweight mode, it will take less time, okay, because its parametric data cannot load here. So when you opening the file, you have to first think what I have to do in the assembly when I opening the file, okay, whether I want to change the parameters or just want to change the geometry or graphics of the model. So you can use those two tools to open the file. In the lightweight mode, obviously you can add mates, you can select geometry, you can measure and mass properties. You can also explore interference detection, dimensions and section view. These all you can create in the lightweight mode. Okay, so if you want to do this task, please I suggest you use the lightweight mode. The third mode of the assembly view is the large design review mode. It is very super fast and it only loads the graphics data. Okay, when you open the assembly in a large design review, one a window will open and it will says that you can navigate, you can select and open components, you can measure distance, create cross sections, hide show components, or you can also create walkthrough animations in the large design review mode. If you select large design review mode with editing assembly, you can also insert components, you can delete components, move, rotate and create, edit, delete mates also. So this task you can perform inside the large design review mode. Okay, in the left hand design feature design tree, the large design review mode does not display any featured tree. Okay, because it just loads the graphics data, but other tasks you can perform, like if you want to measure some dimensions. Okay, so you utilize the evaluate measure tool, select the objects in between you have to measure. It will shows that the measurement will not be accurate, but it will give the approximate data. So just select the two object, it will give you the dimension. Likewise, if you want to give the some different views, you can also do that inside the large design review mode. You can also take the snapshot of it before to review the your assembly just for the review purpose. You can also edit assembly in the large design review mode. Okay, suppose you want to add any component inside the assembly, just select the insert button, select the component, and there you go, you can add your component in the large design review mode. Because you are not editing the existing assembly, you are just externally add those data. So if you want to do this task, please use large design review mode. You can also set the large assembly mode. If you want to automatically open the files in a particular modes, just use these system options in the assembly. For the lightweight mode, I have selected 500 components. When I open the file which has a equal to or more than 500 components, it will automatically open in lightweight mode. If I have more than 5000 components, equal to 5000 components, it will automatically open in a large design review mode. Okay, so keep these settings handy on your performance. If your 300 components you have to open in a lightweight mode, just add those 300 in these parameters. Also you can set the large assembly settings, where when you select the check mark of the large assembly setting, it will mark you it will open the assembly those points where all the check marks are highlighted in the slide. Okay, so please select those check marks wisely, what data you want to show in the assembly. This is example where this assembly has a 1487 components. Okay, in a fully resolved mode it takes 33 seconds. Okay, in the large assembly mode it takes 16 seconds, and lightweight mode 16, and large design review it only 6 seconds to load this assembly into the graphics or into the software. So that is how the opening time will reduce. What can you do in the large design review? I already stated that you can create the snapshot. You can also create a walkthrough of the assembly. So if you want to show some assembly to some your manager, your customer, or anything, anybody who want to just see the assembly, you must open in the large design review mode, where you can create this kind of task. Okay, you can measure, you can take the section view, you can navigate, hide show components. Okay, you can selectively open and edit the components. What about drawing? Okay, so this is for the assembly, but we also make the assembly drawings. Okay, so for that purpose also has 4 different kind of viewing modes. Okay, if you just want to view the drawing, use a quick view mode. If you want to check the detailing of the drawing, use detailing mode. If you want to create the drawing for the lightweight assembly mode components. Okay, so these 4 modes are available for the drawing also. So we have seen the assembly various assembly modes, where we can use those modes to process our data in the software. Okay, now next we will move ahead to the assembly tools to diagnose the performance of your assembly. uh, there is a one tool available inside the SolidWorks, that is a performance evaluation tool, which is when you open any assembly, go to the evaluate tab of your software, and you will find a performance evaluation command. Okay, it will give you the performance all your data in the assembly components. Okay, it will show the document open file details, it will show the graphics triangle performance, so you can analyze those data and work on it to give boost to your performance. Okay, it will show the file statistics, graphic triangle count, and other potential warnings like rebuild time, opening time. Okay, these all the performance details you can find in your performance evaluation tool. Another tool to optimize your performance, that is the assembly visualization tool. Okay, in the slides you can see the video where I have opened the assembly visualization tool, where I can graphically color it and order it in a particular parameter. Okay, suppose I want to create the maximum graphic triangle objects, I want to order it. So you can see that the maximum triangle takes and to the minimum triangles take component in a color wise manner. Okay, so this is very helpful to um, optimize your performance of your CAD data. Okay, so you can sort any parameter. Okay, just open that particular part, work on it to reduce that particular parameter, and it will enhance your performance. And the next one is our modeling techniques. We have a different modeling techniques. So what modeling techniques you have to follow, so it will boost your performance for the larger assembly. The first modeling technique is sketch fillet versus fillet features. I have already tell you, if you create n number of fillet features, okay, it will contribute to the graphics triangles and leads to the performance. If you add some sketch fillets inside the sketch, it will reduce that feature because it not create a separate feature. Okay, that will obviously reduce your performance. Okay, so you have to think whether I want to create a separate feature, okay, for the modification purpose, or I can just okay with the fillet in the sketch. So you have to decide that. So this is the modeling technique tip 1 for the assembly performance modeling technique. Second modeling technique, use simplify geometry. Okay, I have seen a lot of user use the thread feature or cut revolve feature to create the threads for the bolts. Okay, it is not necessary because we are not manufacturing those parts. Okay, we are just purchase it from the market and just get it. We are not creating drawings also. If you want to add the threads look like feature, just give the cosmetic threads. Okay, it will just import those images so the other can understand this has some threads on it. Okay, but please I suggest do not add the thread feature or helix feature, because you creating those extra feature and those nuts and bolt are not single and double. It tend to maximize to 1000 or it depend on the assembly. Okay, so that multiply n number, it leads the performance. Okay, suppose I have two compartment, that is a fastener with no threads and fastener with threads. Okay, if I insert the 25 fasteners, look at the triangles, 4725 triangles only. If I add those 25 fastener with threads, look the triangles, 39,125 triangles, means that will take time to fill those graphics for the, it will increase the load on the graphics card. Okay, indirectly your SolidWorks performance will take down. So likewise you have to taken care of these thread features or modeling technique. Do not add the unnecessary thread feature. Next is the imported components. Okay, so in your assembly I might see a different imported components. Okay, here I shown for example like motor. Okay, so this is also the bought out part. We don't need that extra feature. Okay, like those ribs. Okay, those detailing nut bolts and all these marketing companies holes and all these visa. Just simplify these imported components. If you are getting any step file, save it in a single body SolidWorks part file first, then add into the assembly. Okay, okay, you have to check the simplify the model, because you want to work on it, right? You want to just use for the representation of it, not just whole detail, because you are not manufacturing that part. Just import and simplify the part file, create basic representation. Other can understand that this is a motor, or this kind of motor. This is a foot mounted or flange mounted motor. That's it. No extra data we need to represent in the assembly, because it will ultimately give you the performance in your CAD assembly. Next, the major importance is the appearances. Lot of user gives n number of appearances for different faces. Okay, so here is one example I just explain here. The in the left hand side, that model has a surface body 8644. Why? Because this has appearance on the 8644 faces to this model. So it tends to graphic triangles and ultimately number of appearances. Okay, so you can see in the right hand side the model, I just eliminate those appearances for the faces. I just simply add the appearance to the single body. You can see the graphics triangles. So whenever you are applying appearances to your model, just select the body of the appearance. Okay, when you go to the when you add the appearances, you will notify that there is one small manager will open, where you can select the face, edge, or feature or body. Okay, appearance, I will try to some common faces you can add the appearances because it is necessary, but appearance we are adding for the material for the particular object, not for the particular face. Okay, so if you apply the appearance for the different faces, it will accumulate and create the graphics triangles indirectly. So whenever you applying the appearances, make sure it will contribute to your body, because when you creating drawing for that body, it will automatically create that hatching type also. Suppose I want to create a solid shaft or the steel material. If I apply that material, it will in a drawing view, it will if you take the section of that view, it will give you that cross section. If you apply the wooden material, it will give that cross section. But if you add the appearance to the outer cylinder of that shaft, okay, it will not add that cross section, because you don't add the whole material to the body. Likewise, you have to very careful for the appearances, because it takes time to graphically enhance those graphics triangles. Next is the fully defined components. Okay, do not uh, any assembly part should be your fully defined. Fully defined means it has some complete degree of freedom, because what happens when you create those undefined objects in the assembly, the RAM and CPU takes time to calculate those data, calculate those mates, because it is not fully defined in XYZ direction. Okay, so whenever you are creating assembly, make sure it is fully defined. If there is a sub assembly who is flexible, make sure that flexible assembly has fully defined components. Okay, so it will take less time to calculate those, process those data. Okay, if you are using any fasteners, you have the one option that is lock concentric rotation. So whatever the concentric mates you are adding, it will automatically lock all that rotation. That option is available. If you have too much hardware for your assembly, okay, so go to the system setting, whole wizard setting, and remove check mark those lock rotation for new concentric mates to toolbox components. So whenever you add the assembly components, fasteners, it automatically lock that rotation, because it extra degree of freedom it will create. So software takes time to rebuild those mates. Next modeling strategy is the use weldment command manager, yeah, command. Because if the body is going to manufacture in a single part, okay, for example, I have shown the image here, it will indirectly leads to a single part after welding is has been done. Okay, so please don't make it is a assembly, because it contribute to a different files and different mates. Okay, because it is not needed. You will get all the bill of material for uh, this assembly or this part inside the weldment too. Okay, so please make sure whatever the welding is happening in a single part, please use the weldment command tab. Okay, it will give all the details which is required for the manufacturing point of view. Okay, so you can see the same file I have created in an assembly. Now you can see I have add those files, add the mate. Okay, and then I have created the assembly. So these extra process I have to create for creating this type of assembly, because there is no need, because it will ultimately create a welded body. So please create those bodies in a weldment feature. Okay, like I said, in the weldment domain you can also get the cut list, what we can say a bill of material, which is required for for procurement of that data. Okay, it is customizable wholly. You can add those columns that you require, like quantity, description, material. Okay, you can also customize those tables inside the weldment cut list. So please make sure you use the weldment command. Configurations, you can use configurations to minimize the load on the graphics in the assembly level. Suppose you want to create the assembly, you want to create a component with a very high feature rich model. Okay, so when you put in the assembly those component in the those component in the assembly, you have to create a very simplistic version of it, like we have said in an imported component, right? Because in the assembly we don't need that extra detailing, we just need the representation of it. Okay, so please use the configuration for the simplified version, so you can add those configuration to the assembly level. Okay, so it will just represent there, it is not needed that much detail in the assembly. Okay, some SolidWorks system option I will show here that will leads to your performance. In the large setting, please use that large setting option, use that image quality setting option. Okay, keep it as low as possible because it will take unnecessary accuracy of graphics data, not accuracy of the data. Okay, utilize to the lower side. Okay, for the shaded and as well as wireframe options. For the display setting, use anti-aliasing settings, check for the none. Highlight all edges to be unchecked for the dynamic highlights from the graphics view. Okay, for the feature manager, uncheck the dynamic highlight. For the performance, uncheck the verification on rebuild, ignore the self intersection checks. This you have to uncheck all these settings. Okay, automatically optimize the resolve mode. So software has algorithms that can optimize your loading capacity. Please use that. Also there is a one enhancement, enable graphics performance, requires SolidWorks restart. Okay, when you select the image quality to the lower side, okay, I know that the circle will look like hexagon or pentagon or maybe octagon. Okay, depends on your circle geometry, right? But if your data is performing, you still select those circles. Okay, it might look like the hexagon, but it is a, I know, we know that it is a circle. Okay, so you can also still select those surface or cylindrical faces or edges as a circle. Okay, so don't fall into that trap because it represent not actually the hexagon. You can also take these assembly settings that I have explained earlier, opening large assembly settings. For the assemblies who has a very less components, you can open in a fully resolved mode. Those assembly which has a mid range of components, you can open in a lightweight mode. Or those assembly who has a very large components or very huge components for the hardware capacity, so use LDR mode, light design review mode. Please update your assembly to the up-to-date version, because a lot of people do their assembly and use a different version of the SolidWorks component. Like suppose I am doing my assembly in a SolidWorks 2023 version, but when I inserting the components, okay, it takes me to the 2018 or 2019 components. So before opening the assembly, please update all your file data. Okay. So for that purpose, we have SolidWorks Task Scheduler software inside the add-in for the SolidWorks. Okay, you just search in the SolidWorks Task Scheduler. You can convert lots of tasks which is backend without you can schedule your task. Okay, you can convert those drawing files into PDF without opening all the stuff. You can convert directly the SolidWorks file to the latest version. Okay, you just have to add those files and set time and date. Okay, it will continue to the schedule, complete the task in the backend. Okay, you don't need to add those files again and again, it will automatically create those tasks, so you can schedule your task. It has very huge capability. Use this tool. Okay, use this opening status command manager, because it shows which component has take too much time to load. Okay, so this command manager you have to see. Okay, if your assembly feature manager design tree is very large and very high in a width, so you can also optimize that. For that purpose, what you have to do, you have to just analyze those data that the part file name. Okay, this one is called as the instances that we have put into the assembly. These ones we can say the configuration name, and this is the display name. Okay, so this is the nomenclature. For that purpose, we have to think what we need to see here. Okay, just right click on the assembly file name and select the feature design tree options, where you can unselect do not show the configuration and display name state. Okay, so your the naming data will be reduced likewise, so it will not display the unnecessary data. So your width of the visibility reduced. Okay, you can also search your components into the feature manager design. You don't, if you want to create if you want to see the components, don't just open the feature manager tree, expand the all the stuff. Just search in the search bar tool, where you can search for the particular component. You can also, I already said that you can lock the rotation for the toolbox component, so it does not necessarily rotate inside the assembly. You can also save some standard views you want to see again and again when you open the file, like some customization display views you can set, so you don't need to zoom, rotate and pan those views. Okay, because you want to see those particular area zone, just save it in a display zone. Okay, so you can very easily navigate from those views. Okay, you can also rotate, pan and zoom using the entities of your 3D model, like edges, face. If you select the face, it will rotate in that particular direction. Okay, you can also create this kind of walkthrough animations. Suppose you want to give that kind of animations to the customer. Okay, so you can also create without sending him a very step file, huge step file or part solid file. Okay, it will understand how the detailing was done inside the SolidWorks, right? So you can create this kind of animation inside the SolidWorks walkthrough animation. Okay, suppose you have very huge mates, you can also group them. You have to search for the particular mates. Okay, you just see the breadcrumb here. For the particular part, it will show the mates. Okay, suppose you want to see in another way, you just view mates option available, which is very handy. You can select that particular parts as mates with its reference elements, so it is very easily you can navigate those part assembly mates. You can later on modify those mates. Okay, so please use this tool to enhance your performance. Okay, you can also see the different mates available. You can also group them according to their status. Okay, if it is a solve mates, it will group in a solve mates folder. If those suppress mates, it will group in a suppress state. Okay, so you can use this to minimize your feature manager design tree very less. If it is a fastener mates, you can also group that in a fastener category mate. Okay, so again, some SolidWorks assembly tips. Please remove your temporary files from the PC, because it ultimately loads in the RAM. So please take a habit to daily clean up those temporary files. Just search for the temp files in the start bar menu, okay, and just remove those temporary files because it ultimately loads in your RAM continuously. Okay, so please take a habit daily one time you have to clean those temporary files. Weekly clean up your SolidWorks temporary files. Okay, for that purpose, you just search SolidWorks RX tool, which I uh, take the image of it, how it look like. SolidWorks RX tool, where it open, it show you the option system maintenance. Okay, where you can check those temporary files and clear weekly basis. Please use these tools to enhance your performance because at the back of the end these files are performing. So please use this habit to clean up the temporary files daily and weekly for the SolidWorks temporary files. Okay, so that is how you can boost your performance inside the SolidWorks. So I have shown to explain you how the different strategies can boost your performance inside the SolidWorks assembly. If you have some questions, please ask me in the chat box so I can give the answer of it. If you have any doubts, if you are facing any problems, please let me know in the chat box so I will try to give the answer of it. Before that, I just want to know that is this webinar is helpful for you or not? Is this relate to your day-to-day life? Please let me know in the chat box. Okay, some more people, please. Is it helpful? Okay, thank you very much. So, hi, this is the challenges I also face in my the starting phase. So please use these strategies to enhance your performance, so your productivity will increase. There is one question: is there any option by upgrading hardware for performance? Look. From the performance you will get to know the idea the how my assembly, how my SolidWorks will perform. Okay, so if you opening any file, you find you did all the strategies that I have explained here today. Okay, still you find some lagging and some uh, performance issue. Please uh, take your hardware configuration to check, verify the SolidWorks certified graphics hardware. If it is not, then you have to upgrade your hardware systems because it has not that much capacity that can perform your handle your data. Okay, as simple as that. So you have to take the decision that I need upgradation or not. There is one question, Mike. How to generate split parts in assembly module? Mike, this is not the scope for right now. You can reach out to me later stage. I will take the answer of it, but it is not the today's webinar's point of scope. Any more questions? Please, if you have any doubts, please let me know. If you have any doubt, please ask the question in the chat box. We will open this question scenario for the next 1 minute. Okay, there is one question. I have 8 GB RAM, so is it sufficient for good simulation? That's again the I already tell that we have four factors. We have CPU, we have RAM, we have graphics card, and we have SSD drive. These four factors, these four hardware contribute to our performance, not just RAM. Because what the function of RAM, it stores the data temporarily for processing the CPU. Okay, if CPU needs more data but it is not available in the 8 GB RAM, then how can the process will again happening? So you must need more than 8 GB of RAM to process that CPU data. Okay, that CPU hungerment, we can say that if CPU is hungry, you need more feed data, right? So this is very logical terms. You have to understand these logical terms. If your simulation demands more data to process, you have to upgrade your RAM. And then next question, can I use configuration in large assembly? Yes, you can use configuration in large assembly too, but you have to first decide whether your large assembly opening very smoothly or not, because if it is opening very it lags or it takes some time to perform very well. So please correct those assembly and then you use configuration tool, because if you add one more configuration, it will again create the performance triangles or graphics triangles. Okay, any more questions? Okay, then thank you very much to attending this webinar. If you have any doubt later on the stage, you can reach out to me. These are our email IDs and website that I've shown in the slides. If you want to physically visit to us, I also share the location of it and contact number. Please reach out to us if you have any doubts and need any performance issues. Please contact us. And if you have a suggestion or you want some demos to these softwares we are selling, just contact us. We will very happy to serve you and give you the demo for it. Okay, because these all are softwares we are selling, which is very top-notch technologies we currently going into the industry. So please aware of with this technology, so you can create good career growth in your paths. Okay, so you will know that these technologies are existing and we can utilize for our better future. So thank you very much all joining for the webinar. See you next time. Thank you very much.